All right, so here's lesson 3.1. This is part 2 of it. And as I mentioned, we're going to go back now and convert the other way. If I gave you a radian measure, could you convert that to degrees? Before we do that, though, there's one fact I should have mentioned in the first video, and I forgot all about it. And the question is, how big is 1 radian? And so let's think about this for a second. 180 degrees, we said, is the same thing as pi radians. So if we divide both sides by pi, we get 180 divided by pi. And let's see what 180 divided by pi is. 180 divided by pi. And a radian is 57, it doesn't come out exact, but about 57.3 degrees. So 1 radian is approximately 57.3 degrees. All right, and that's another fact. We won't use that one to convert things because it's not exact, but it's a good fact to keep in mind when you're thinking about a radian. How big is a radian? About 57 degrees. Okay, now let's convert backwards. We're going to go, these are radian measures. How can you tell? Because look, there's no units on them. If there's no units on a measure, the assumption is those are in radians. Let's switch it to degrees. We'll use our conversion factor. Look, it was right here. 180 degrees is pi radians. Now the degrees end up on top because we want degrees for our answer. So multiply by 180 over pi. Look how nice this is. The pi's are going to cancel out. I get 180 over 6. And 180 over 6 is 30. And I better put units on it. 30 degrees. And if you think about that, that makes sense. Because we said pi is about 57, roughly 57. Pi is 180 degrees. 180 divided by 6 is 30. All right, not bad. Try it again. This is radians. Is it really this simple? It is. Multiply by 180 over pi. Oh, look at that. Pi's cross cancel. 4 goes into 180. Check that out. 45 times. And what's 7 times 45? Looks like 315 degrees. Nothing to this. Okay, what if they don't put a pi in it? That's okay. Same conversion factor. We want degrees, so degrees are on top. So 1 times 180 over pi. The pi is not canceling out with anything, so good time to pull out your calculator. And I've got a 4.21. I've got it times 180. And I'll divide it by pi. And what do I come up with here? 241 degrees. Makes sense. We said a radian was about 57 degrees. We had a little more than 4 of them. So at 241.2 degrees seems to make sense. 241.2, don't forget your units. 241.2 degrees. All right, 7, almost 8 radians. Well, let's see. I'd take 57.3 times a little less than 8. Are we thinking about 400 or 500 degrees this time? Hopefully, is a ballpark. So times 180 over pi. Scoot that out of the way so we can see it better. 7.87 times 180 divided by pi. What do we get? Yeah, right in the middle there. 450.9 degrees. Okay, so just to recap that, 450.9 degrees. If they give you radians, a different color, if they give you radians and you want degrees, we'll multiply by the unit with the degrees on top and just go back a page. If they give you degrees and they wanted radians, we'll put the radians on top, times pi over 180. So we have this conversion factor. Pi radians is 180 degrees. The unit you want, put that on top on your conversion factor. Okay, last thing will be this. Remember your chart with 30, 45, and 60 in there? Well, now we're not going to call it 30, 45, or 60 anymore. We're going to call it things like pi thirds, pi fourths, pi sixths, pi halves. But they will come out to be a 30 or 45 or 60, something nice that was in that chart already. And we just have to kind of think through which values those were. So first of all, you've got your chart. If you forgot your chart, you might want to look that up or just quickly reproduce it. We had the sine, the cosine, and the tangent. Our angles were 0, 30, 45, 60, and 90. We had a 0, we had a half, root 2 over 2, root 3 over 2, and 1. Cosine was just the reverse of that. 1, root 3 over 2, root 2 over 2, 1/2, and 0. Tangent was the quotient of sine over cosine. So those three were easy to get. And the other two, maybe you just remember those. Okay, so now, question is, what's the sine of pi thirds? Well, let's convert pi thirds. I want degrees, so my conversion factor, I put the degrees on top. Look at that, the pi's cancel out. 3 goes into 180 60 times. So this is like asking me, what's the sine of 60 degrees? And the sine of 60 degrees, I can check it in my chart. The square root of 3 over 2. Not bad at all. We can do the other problems, and we can convert it every time. Or, why don't we come to our chart and just convert our chart? 0 would stay 0. 60, we said, is the same thing as pi thirds. We can look back at some of the problems we've already done. We've probably done some of these already. How about 30 times pi over 180? Didn't we do that one already? Look, that's going to be pi 6. Makes sense. That's half as much as 60 degrees. 45, you can check it out. That's going to be pi fourths. And 90 degrees, you can try that one as well. That would be pi halves. So maybe you want a chart with both the degree and the radian measure in it. And then you've got everything at hand there. You just know 30 is pi 6, 45 is pi 4, 60 is pi thirds, and 90 is pi halves. Kind of strange, not strange, but maybe initially strange, how the numbers decrease, which makes sense. The new denominator of your fractions decrease, which makes sense because by those decreasing, that makes your whole fraction increase. So I want the cosine of pi 6. I just look it up. A little sloppy there, but it's the square root of 3 over 2. Done. Tangent of pi fourths, just look it up. Look, right there. 1. Cosecant of pi halves. Cosecant is reciprocal of sine. So it's 1 over the sine. Pi halves. Sine of pi halves is 1. 1 over 1 is 1. So a very quick, easy way to do these problems. And the easy way to do it is add another column to your chart with both the degrees and the radians. All right. I think I have one more page of these, but I think you've got the idea. You would use your chart. Oh, wait. I'm sorry. A little bit different here. Our chart doesn't work here. These are off the chart, aren't they? 2 pi thirds is bigger than that. So let's convert 2 pi thirds with our 180 over pi. Pi's cancel out. 3 goes into 180 60 times. I have 120 degrees. What's my reference angle? Look at that. 60 degrees. What's the cotangent of 60 degrees? Well, it's the reciprocal of tangent. Tangent was root 3, so I get 1 over square root of 3. I rationalize that. I get square root of 3 over 3. But wait, second quadrant, a smart trig class. I don't know how many times you've heard that. Second quadrant, tangent and cotangent are negative, so I get negative root 3 over 3. Cosine of pi, I'm sorry, secant of pi. Ha! That's an easy conversion, isn't it? Because pi is 180 degrees. What's your reference angle? I don't know if we've done this one before. What's your reference angle for 180 degrees? Well, it's right here in the second or third quadrant, so I'll use 180 in my calculation. I go 180 minus 180. My reference angle is 0. What's the cosine of 0? 1. The secant is a reciprocal, so the reciprocal of 1 is 1. So I get 1 for my answer. If you do a smart trig class, you realize if you call it either the second or the third quadrant, don't fight over it. Either way, it's negative. So I get a negative 1. And here's a cosine of negative 7 pi 6. Let's convert that thing. 7 pi 6 times 180 over pi. Pi's cancel out. 6 goes into 180, 30. Negative 210 degrees. All right, first thing I'll do add on a 360. So this is equivalent to 150 degrees. Reference angle is 30. What's the cosine of 30? Square root of 3 over 2. But wait, second quadrant, A smart. So I get a negative answer. And that pretty much concludes our first section. This radian measure, we know pi radians is the same as 180 degrees, and we'll eventually start thinking in radians, but for right now we're just making the conversions. And that completes our video.